Okay, today we're going to talk about solving by factoring. This is the first tool that we're going to use to find the zeros or the solutions or roots of quadratic equations. So our steps are right here. We're going to first get the equation equal to 0. A lot of times you'll be given an equation that's already equal to 0. If not, you have to move everything over to one side of the equation so that you have usually all of your coefficients and x values on the left side and your 0 on the right. Then we're going to factor that equation. So break it down into the smallest parts we can. Then we're going to set each of those factors to be 0. And then we're going to solve for x. So the example up here, we have x squared minus 4. If you notice, you've got a subtraction here. 4 is a perfect square. X squared is a perfect square, so we can use x plus 2 times x minus 2 to factor it. We set each of these equal to 0, so we'll have x plus 2 equal to 0, and we'll have x minus 2 equal to 0. Solve that for x. This gives us x equals negative 2, and this gives us x equals 2. Okay? And these are our two solutions. Okay? And the one thing we want to keep in mind is that a quadratic equation will have two solutions. They may not be real, so you might have imaginary numbers or complex roots, or you might have one root that is a double root. All right? And we'll see some examples of that, and I will mention it each time we see it. All right, so let's get into solving by factoring. For number 1, we need two numbers that multiply together to give us a 6 and add together to give us a 5. And the other thing that we should be noticing here is that we've got a plus. Now let's make this a little nicer. This plus here at the end tells us that the sign in our two binomials is going to be the same. Okay? So let's get that set up. So we'll have two binomials here. Right? Whatever sign is in here is going to be the same. So they'll either both be positive or both be negative. Right? We have x squared. The only way to get x squared this way is to multiply x times x. Right? So for this, the terms inside, we need something that's going to multiply to 6 and add to 5. Right? So we're going to multiply to get this last term, and we're going to add to get this middle term. Right? The only two numbers that do that are going to be 2 and 3. And if we want to add to get to 5, they need to both be positive. Right? And if we want to check, we've got our first terms are going to give us x squared. Our inner term is going to give us 2x. And our outer terms are going to give us 3x. Right? That will give us our 5x. And that's how we check when we're factoring, but we don't need to do that right now. That's not what this unit is about. This unit is about solving. All right? So whenever in doubt, multiply it back out and check that you got your factoring right. Now we're going to set both of these factors equal to 0. So this is going to give us x plus 2 equals 0. And this will give us x plus 3 equals 0. We're going to subtract 2 from both sides. This will give us x equals negative 2. Subtract 3 from both sides. This will give us x is equal to negative 3. So our solutions are negative 2 and negative 3, or we can write that in set notation. Excuse me. Next, we're looking at number 2. Right? Here, we are going to be factoring. We need to multiply to get to 4, and we need to add to get to negative 3. Right? And actually, when we multiply, we're getting negative 4. Right? And then also here, we want to note that this negative sign means that we're going to have different signs. Right? So when we set this up, we're going to have x plus something, and we're going to have x minus something. Right? And because there's nothing in front of this x squared, we know we don't have to worry about leading coefficients. So things that multiply to get to 4, there's not too many of them. You have 1 and 4, and you have 2 and 2. 2 and 2 don't add up to give you a 3. 1 and 4 will. Now, we want a negative 3 in the middle here. So we're going to have our 4 be negative and our 1 be positive. So then we multiply this out. This is going to give us a negative 4x, and this will give us a positive 1x. Negative 4 plus 1 will give us that negative 3 middle term. So now we set both of our factors equal to 0. This will give us x is equal to negative 1, and x is equal to 4. Okay, number 3 here, this one is going to get a little more interesting because we've got this leading coefficient here. Right? So we can try to bust out our binomial pairs, or we can do the area method. And I think here the area method is going to give us an answer quicker, so I'm going to do that. But before I do, I want to note that right here, this negative sign here means that our signs will be different. So when we're making our binomial pairs, we know we're going to have a plus and a minus. We just don't know what's being put in there yet. So let's come over here and give ourselves a little bit of scratch area. Right? And this is to get our box going. So in this upper corner, we want our first term. That's going to be 2x squared. In our lower corner, we want our last term, and that will be negative 4. We're going to cross multiply here. This is going to give us 8x squared. Right? And down here we want to list out, negative. Got to be careful about that. We want to list out our terms, our possible numbers that multiply together to give us negative 8. And keeping in mind that eventually we want them to add to give us a negative 7. Right? First, the easiest one, we're going to have 1 and negative 8, and we'll have negative 1 and 8. Right? And if you notice right away, 1 minus 8 is going to give us a negative 7. So that's going to be our answer. And we can stop right here. Put 1x here and negative 8x here. It doesn't matter which corner you choose. Either way, you will get the same answer. Right? So we're going to come up here, and we're going to find our GCF. Right? So between 2x squared and x, our GCF is going to be x. Between negative 8x and negative 4, our GCF is going to be negative 4. Between positive 2x and negative 8x, our GCF is going to be 2x. And then between negative 4 and x, our GCF is just going to be 1. That's the only thing they have in common. So we're going to read along here and here to get our factors. This is going to give us 2x plus 1 and x minus 4. And we're going to go back up here because I want to make sure that I'm still doing everything that I expected to and said I would up here. So here, our signs are supposed to be different, and look, they are. If we want to multiply this back out, just to check, this will give us 2x squared. This is going to give us x, right? This will give us negative 8x, right? So 2x squared plus x minus 8x, and then this will give us our minus 4. And then sure enough, that's 2x squared minus 7x minus 4. So this is just our double check that we factored correctly. And then I'm going to take this away because our problem that we are solving here says to factor and solve, right? So we're still going to have that equal to 0, and then we're going to set each factor equal to 0. So this is going to give me 2x is equal to negative 1. this will give me x is equal to 4. And then this one will give me x is equal to negative 1/2. So these are our two solutions. And again, you might see these in set notation. You just have to know what that looks like. Next up, we're going to look at x squared minus 6x plus 9. Let's get a green pen out just to have some fun. All right, we want to factor. Here, this means that our signs are the same. Right? And this is negative. The only way we're going to get a negative is if we have our negative in our binomial pair. So we know that these are going to both have to be negative. All right? We've got x squared by itself, so we know we'll be starting with x squared. And then there's a couple of things you can notice here, but I'm going to go with the basics. First, we need to multiply to get to 9. And we need to add to negative 6. All right? Things that multiply to get to 9, we have 1 and 9, doesn't add to 6. And we have 3 and 3. That does add to 6, right? If we want negative 6, we have negative 3 and negative 3, right? And then this could also be written as x minus 3 squared is equal to 0. But either way, we're going to have x minus 3 equal to 0 and x minus 3 equal to 0. These are the same, so we only have to do one of them. So x is equal to 3, right? Because this is going to give us the same thing. We don't need to write it again. But if you remember from before, I told you that this is a double root. Anytime you have a quadratic that only has one solution, that's going to be a double root. Right? And this is going to be important later when we are multiplying back out to recognize situations where you have one root that is well, basically wearing two hats. So over here, we've got 5t squared minus 25 is equal to 4t plus 24. So when we were talking about our steps earlier, our first step, we had to get everything equal to 0. So we're going to have to do a little bit of subtraction here. So we need to get this 4t squared over here, and we need to get this 24 over here. And so we're going to subtract these from both sides. We are going to have 5t squared minus 25 minus 4t squared minus 24 equals 0. Then we've got some like terms here. So we're going to combine those. 5t squared minus 4t squared is going to leave us with t squared. Negative 25 minus 24 is going to give us minus 49 equals 0. Now, if you notice right here, we have a subtraction. And this is a perfect square, and this is a perfect square. So we can use our shortcut and say that this is t plus 7 times t minus 7. Because we have a difference of perfect squares. If this was a plus, we could not do it. So this is going to be t plus 7 equals 0. T minus 7 equals 0. T is going to be negative 7 here, and t is going to be 7 here. Right? And those are our solutions. And again, you can write them either way. I just want you to be able to recognize whenever you see that.